Good morning, everyone. My name is Wilfredo Zelaya. I enrolled in the Master of Science Space Studies program at American Military University with the Aerospace Science concentration in October of 2021. I will soon complete the degree requirements in April of 2023. This recording will serve as my 4-minute thesis assignment. The early courses of this program had us study surface level topics on astronomy, space policy, aerospace science, and space entrepreneurship. Coincidentally, these were the concentrations available for this master's degree program. I chose to study aerospace science because I have worked in the aviation industry my entire adult life, spread out through 10 years in the Air Force and 5 more in the civilian sector. The aerospace science concentration has us deep dive topics such as orbital mechanics, aircraft and rocket propulsion systems, satellite communications, aerodynamics, and aircraft design. Some of my favorite topics included jet engines, ram and scramjets. I also enjoyed discussing the various types of fuels used in rockets, such as solid and liquid fuels. It is interesting how rockets release emptied fuel tanks to decrease the weight of the projectile being propelled into outer space. Early in this curriculum, we discussed how underfunded our American space sector has become in recent decades. The lack of funding is because, as Americans, we tend to ask, how will this benefit us? The following thesis presents a valid response to this question. The Parker Solar Probe launched on August 12th of 2018 en route towards the Sun. The PSP's primary mission is to explore the Sun's corona and space weather system. Venus flybys will aid the PSP as it gets closer and closer to the Sun. The PSP will cover about 95% of the distance between the Earth and the Sun. The data gathering venture will benefit us on Earth greatly. In order to survive this expedition, cutting-edge technology was designed and implemented. For example, a 4.5-inch thick carbon composite heat shield that can withstand temperatures as high as 3,000 degrees Fahrenheit. Solar panels help generate electricity for the cameras, sensors, and other vitals. Furthermore, light sensors detect sunlight when heat-sensitive areas are exposed to the sun. AI repositions the heat shield to correct this exposure to protect these critical components. A wide field imager for solar probe is also attached to the PSP to take high-resolution images of the sun's corona in visible light. These images will provide scientists with better insight into the corona's physical properties such as density, temperature, and magnetic field, information that can be used to understand how solar winds affect the Earth's environment. These components are a small sample size of the many advanced technology components that will ensure the PSP completes its stated mission. Knowing how the sun's activity affects space weather is vital in learning how the Earth may be affected. Radio communications, for example, are vulnerable to interference from solar flares, which can cause radio blackout storms. The dangerous effects of space weather can disrupt the Earth's power grid. High levels of solar activity increase radiation, which mandate specific safety protocols for spacewalks, air travel, near active sunspots. Such information is also essential when addressing potential disruptions to communications due to conditions like coronal mass ejections. A better understanding of energy from the sun's interaction with Earth's atmosphere makes for more precise calculations regarding future technological advancements. Remaining unaware to these potential hazards would prove catastrophic. If our satellites and radios become obsolete, we rely on them for daily activities as broad as sending emails to traveling by car and airplane. Completing this degree will help me develop in new roles within the aviation industry. Thank you for your time.